Hello everyone, and welcome to the tutorial for Gearotic 2.0. This tutorial is being made to bring everyone up to date on the new GUI. I get a great many letters from people asking me if the videos are newer or older, and many of them are older videos, of course. We don't take the videos offline. They elucidate a concept, and the concepts don't change, although the graphics do, and the locations of buttons and so on do. In this video, we'll just take a look at the GUI as it now stands in Gearotic 2.0. For those that haven't followed the progression, originally there was a program named Gearotic Motion. Gearotic Motion was only meant to give DXF outputs of gear outlines, non-circular and standard. It was an interest I had at the time. It turned out to be fairly popular though, so over time it's grown to do quite a bit more. And because of that, the program had to change completely at one point in order to update its architecture. So it's now called Gearotic 2.0. The interface that you see on the screen is the current one, and we'll use that. I've put two gears on the screen just so that we can use them as examples as we go through what all the menus and so on do. So in a nutshell, this is a video on how to use 2.0. You should watch the other videos to get a better understanding of each of the modules that we deal with as we go. So let's take a look at our top menu. Right to the far left we have Project Tools and Status Bar, and this is just a way of turning off those items so that you can get a better look at things that are on your screen. There is another way, and it's Alt 5. If you press the Alt key on your keyboard and the number 5, you'll instantly go to the screen that you see on the video now. Another Alt 5 will take you back to where you were. When I'm rotating the items on the screen, I'm doing so by pressing my center mouse wheel button. When I press the center mouse button, you rotate. If you press the left button, that's for selecting an item. If I point at an item and left click it, it will select and turn blue. Blue gears are normally the selected gear. The right mouse button allows me to pan the gears back and forth and up and down, and this is true in any orientation that I might be in. If I rotate the gears to look from the left and then use my pan button, I'm panning back and forth in the Z-axis. At the top of the screen is Headley. He is a vision of you. If he's looking straight at you, that means you're looking straight at the screen. If Headley looks down, that means you are looking down at these gears, so you are on top of the gears. So Headley is there just to give you a clue as to which direction you might be looking. You'll find him useful when you are actually placing items on the screen, but we'll get into that later. We have a transparency button. The transparency slider makes gears go transparent. This can be handy when you have multiple gears in a project and you want to see through them to see the faces of the other gears. By default, it is left all the way to the left where everything is visible. We have a measuring tape. If you click measure, a message appeared on the screen for a split second saying drag your measuring tape. So I could drag from the center of a shaft, for example, to the center of a shaft and see the distance on the screen. That distance is called a hover message, and it will stay on the screen until you switch modes or do another measurement. We also have a simulate button, which allows the gears to begin to rotate. In a simulation, you have a master and the rest of the gears are slaves, and the master is always in dark black up on your project tree, so it is this driver gear here. You can set different masters, but if you do, you'll have to relink the gears together so the program knows the logical sequence in which to drive the gears. You'll find that, I believe, in the Gearotic Motion 1.0 tutorials earlier on. We can reverse our simulation. We can speed it up or slow it down. You will get some visual effects when you speed it up or slow it down. You can get it to the point where it looks like one gear is sitting still or just the spokes are moving, as in this example. This is a trick of synchronicity. That gear is rotating very quickly, and it's rotating so quickly that you can't see it move. Its teeth are in the same position every time. The spokes, which are not at the same angular relationship, can be seen doing a slow motion, and it's sort of like looking at the wheels of your car. It's all an optical illusion, really. Normally you wouldn't be going that fast anyways. We have an audio button, which you can turn on and off audio in the program. Things like escapements make ticking sounds. Messages as they go up the screen will make a chick sound to let you know that a message has popped up there. We have timing marks that we can turn on. Timing marks are used to check to see when gears will end up meshing the same tooth to a space. It's a good idea when you're designing a gear train to make sure that the same tooth doesn't always mesh in the same hole, because that'll create a particular wear pattern in that gear. You want that tooth to fit in as many holes as you can within the specs of your design. So if you turn on timing marks, you get to watch and see how long does it take before that tooth meets up with that space again. And as you can see, we're one tooth off after one rotation, and because these gears are one tooth apart, it's going to take many turns, an equal number of turns to the number of teeth on the second gear before they actually mesh up again. Anyway, that's what timing marks are used for. It's noteworthy that on the screen at present you'll see one gear has spokes and the other gear doesn't. This is because one of the options that have been set in the options menu saying do not spoke a gear which is smaller than a set size. And while we're on that topic, up at the top left side of my screen, you'll see there's a bunch of little buttons that are icons for various operations like new project, load a project, save a project, etc., save as, and there's a little gear wheel that says options, and this is where, if we bring it up, you can set options, such as you can set the size of your CNC table. This is used in the CNC Workbench. You can set a clamp distance, which is the distance around. All these things are explained in the 2.5D CNC video, so I urge you to watch that if you're into CNC. You can say what kind of materials that you want to put onto your gears. If you want them all to be the same, uncheck the auto ink. You can set prologues and epilogues for your CNC code. You can determine whether you're in inch or metric. You can select colors for the screens, etc. It's a good idea whenever you're thinking to yourself, can I do this, that you take a look at the options page and see if there is something which you can do. So once we get past that, we get to the spoking tab. The spoking tab is normally used on the design screens, but it is on the project screen because you do have the opportunity to respoke if you wish. For example, I could click on this gear to the right. You'll see it turn blue. And if I don't like those spokes, I can select a different type of spoke, say a circle spoke. And down here in the Properties tab, which is the tab you'll use on whenever you're dealing with projects, you'll see there is a button called Respoke, and if I push it, the gear instantly respokes. You can change its shaft shape. You can have a round, square, pentagon, hexagon, or an octagon shape as your shaft. This is because if you buy hex stock, for example, it would make a good shaft material. A round shaft hole will go on hex stock, where the hexagonal hole will lock the gear. So that way you can have gears that free float and gears that lock to shaft without actually having to bolt them to anything. Just the shape of their shaft would determine whether a gear is bolted or not. Then we have a coordinates screen, which shows us where our mouse is at all times. A perspective screen, which allows you to look at the screen from different directions, top, bottom, left, right, various ISOs, and the center face means you want to look straight in, and if you hit it a second time, you're looking straight back. If you're designing a clock which you want to run backwards, for example, you want to make sure Headley is facing away from you, meaning you're looking at the clock from the back, which will make your clock seem to run backwards. It's your only opportunity to switch the direction of an escapement at the moment. Finally, on that tab, we have 4 output options, or what used to be 4 output options in the old videos. Now it's 3 output options and a question mark. Let's do the question mark first. If you press it, you will come up with a screen which has several HTML links to all the old videos. So this will take you to the GUI video 1, which will explain the older Gearotic motion. But again, the concepts are all good between all of these, and usually the only thing that has changed is the location of a button or two. But I urge you to watch these if you have questions on how to use a particular module, because Gearotic at this point actually does probably far more than even most users know that it does, unless you've been investigating a lot of the buttons and controls. We have a printer output. If you hit printer output, you can select any of the objects and tell it to print them. They're printed at a 1-to-1 ratio, which means that a woodworker can stick them on a piece of wood and cut them out with a scroll saw if they wish. If we go back to the project screen, we can see STL and DXF are our last two. DXF allows us to put out anything we select as a standard AutoCAD 9 DXF file. You can also choose to put on crosshairs and pitch circles and so on. 2 things that may not have been covered in previous videos is the shafting DXF. If you press for a shafting DXF, all of the items on your project screen will be printed into a DXF on top of each other. This way you can get an overall view of your mechanism, seeing everything all at once. A summary report will put a text report into your project file showing where all shafts are, distances between gears, and other specifications that you might want to know. You have a choice between 2D DXFs and 3D DXFs. This is really a CAD, more of a CAD specification as to whether or not the third vertex is used. So that's pretty much it for this screen except STL. If we select an STL, we can put it out for 3D printing. You can combine multiple objects by selecting them with the control key over here and putting more objects onto one screen, and you have selections for that. So for example, these two objects will go together as one STL. That can be useful if you're trying to print a mechanism where something runs, like a gear turns on a shaft, and you want to print both at once. If you did do that, however, you'd want to make the shaft a little bit smaller than the gear. Alright, I think that takes care of, for the most part, everything on this top menu bar. So let's take a look at the project screen itself. The project tree is pretty simple, actually. It sorts things by shaft. That is the normal arrangement. You do have a drop down here where you can sort by type or list, etc. But the sort by shaft seems to be the most useful. If you click on a gear, you select it, and if you select it, you'll get some text on the side of the screen. Pressing the control key allows you to select two gears at the same time, or multiple gears. If only two gears are selected, you will get information such as the center distance between the two gears, the shaft ratio between the two gears, and a great deal of other information peculiar to that particular set. If you right-click on a gear, once it's selected, you'll be presented with a menu, and that menu can change from gear to gear, depending on its function. So you can see here I've got things such as set as drive master. You should watch the video on how to do that if you're going to do it, because each of these gears has a linkage to another, and if you mess up that linkage, you have to relink it manually in order to get the simulation to make sense. You can set the time of a master rotation. You can tell the system that you want the system to consider one rotation of a gear to be equal to 1 second or 1 minute or whatever you wish. And that's used for the statistics which show up on the screen when you're selecting gears. Send to design will send a gear back to the design screen, such as we just did here, so that you can see how that gear was designed. What were the specifications of its shift, stub, width, etc. Depending on the gear, as I say, the menu may change. Some of them will give you a send selected to 3-axis workbench. If I was to select that, I would go to our CNC Workbench, the size of which is that we saw earlier in the options menu. Selecting the zoom button can bring in our object. We can select our object with a click, select the auto button to generate a toolpath. Inside the workbench, we can actually tell it to simulate, and it will cut out the material and show us what this cut is going to look like when it's done, using the tool that you're telling it to use. So look at your menu items carefully when you're curious as to how you might be able to do something. When you're on the CNC Workbench screen, a return will take you back. We'll get into that later. So the properties screen at the bottom of the screen allows you to change items in regards to a single or sometimes a group of gears. There is a video on this. You can do such things as move a gear on the screen to another position, move it on a shaft. For example, if I select that gear and say move on gear, I can now rotate it around. It simply goes back into its placement procedure. On the placement procedure, you can see we get an angular relationship in red and blue. We get letters on the screen telling us what our angle is. The gears, when you're placing them, will snap to the 90-degree points, and you'll be given radial distances and so on. So this screen you can kind of look at as a way to modify slightly the items that you already have in your project. That's pretty much how you use Gearotic 2.0 with the exception of its tools. If we go to the Tools menu, we're now presented with a bunch of buttons. Each of the buttons is a module, and we continuously add modules to the program over time. So you never quite know whether or not you're going to have a new button here from a version to a version. At the top we can see we have 3-axis, 4th-axis, and CAD buttons. These buttons should only be used if you're already using those systems. In other words, if you were to push 3-axis, we'll now go to our screen that has our toolpath that we just generated earlier. If we hadn't generated a toolpath, you'd be presented with an empty screen. So it's really only useful to you if you've already been there. 4th-axis you can only get to through your properties menu. If I select a gear that's here on the screen, for example, and you'll see at the bottom there is a send to 4th-axis. This is for machining and takes you to that 4th-axis module. In the 4th-axis module, we don't do graphical simulations, or we don't do material removal simulations, but we do allow for simulations so that people working with a 4th-axis can see how things are supposed to work. It's very simple in Gearotic to do tool pathing in 4th-axis. You can just check a tangential button, for example, and that will shave the teeth on your gear. You should watch the video for this if you intend to use 4th-axis, of course. But it is fairly easy to use, and that's how you get there. I'll show you a simulation while I'm here. And you can see you can get to watch how your tool would move if you were to post this G-code program. It's probably one of the easiest ways to get 4th-axis gear G-code out there that I know of. Alright, we can hit the return key to get out of there and go back to our screen. The tools screen, you'll see we have circular for circular gears. All of these gears are to industrial spec. They're made with single points. They are not replicated with equivalent arcs. Everything is a point-to-point protocol in the output of the profiles. You can select from diametric pitch or module of gears. You can adjust things such as their shift, stub, and width, pressure angles, etc. You can make various types of round gears: spurs, helicals, knuckles, herringbones, bevels. If you have a bevel, you can have a helical bevel or zero bevel. All these things are possible in the circular gear module, and again, watch the appropriate video for it. Under non-circular, you have non-circular gears, which was one of the first things, of course, that Gearotic was written for, and they've always been quite popular. We go with a paradigm now where we do a digital subtraction toothing, so that the teeth on your non-elliptical gears are actually very well formed and follow proper involute rules. And again, you should watch the video on it in order to use it. You will see things change over time, and this is a good example. Here we have a resolution selection: normal, high, and ultra. This is used to minimize the effect you get on a non-circular gear. When you zoom way in, you can see that we have a zigzag pattern here around the curve, and this is created by the digital subtraction of a virtual rack that we use to create these gears. The higher you go in resolution, the more minimized this will become, but eventually I will add an anti-aliasing filter to reduce that in different ways. That's our non-circular. Non-circular includes racks, because of course rack is just a gear which is not circular, and roots blowers, in case you want to build a roots blower. Logarithmic gears are also possible. And that's our non-circular gear. We have cage gears, in case you wish to have pinwheel type gearing. Pulleys that are done to specification. Most of these are now verified. The GT2s were just changed a month or two ago to give us the proper output for a GT2 pulley. Putting them out as STLs is the only way to make some of them, because they are very small and would be very hard to machine. However, there is a very large group of them, and over time we've collected proper specification for the vast majority of them. Next to pulleys, we have sprockets, and again, you can get these in a wide variety of types, from the British and American types to typical bicycle with and without derailleurs. Ratchets come in basically two types. This is a Geneva ratchet, but you can also have a gravity ratchet. The bearings are really only in the program for 3D printers who wish to stress their 3D printer. You should be able to print a bearing, for example, and have it run afterwards if your 3D printer is really of a fine resolution. But they're there in any event for those who wish STLs of bearings. Indicators is an interesting one for the clockmakers among us. We have various styles, and if you follow the topics on the group, you'll find it's actually possible for a Gearotic user to draw their own indicators and have them come out as STLs. I'll leave that for people to find on the forum and figure out how that's done. Boxing is a way to create a box to encompass a project. If I turn on tabs and set a thickness of material, as you can see, it creates like an acrylic box, and I use this output to cut them out on my laser cutter, and you can see that the acrylic that it makes even has holes in it for the shafts. Of course, it doesn't have to be acrylic. You could be making this, for example, out of plywood. We have escapements, several types. We have standard recoil escapements as well as grams. We have chrono deadbeat escapements and chrono recoil escapements. Again, you'll find a lot on these on the forums, and there are videos, of course, on how to do a ticker and videos on escapements in general. There's also a grasshopper escapement for those who feel brave and who wish to make something with a bit of a hop to it. And then finally we have a few options which you're going to find appearing over time. We have image processing, where we can load an image and process it as a grayscale to put out for laser cutters out there that can use it. Darwin, for example, if you're using Mach 4 with a printer port, can use the Mach 4 laser output in order to engrave the objects. But you can also put the object into a project in Gearotic. I have not yet turned on the engraving for things such as photographs and engravable objects, but that will be coming soon. In the same vein as Celtic knots, if you design a Celtic knot, you can put it out as an STL and print it, as I have done, but you will soon also be able to simply go to your CNC page and engrave it using standard CNC tools. For those that want to import things into CAD programs, it is handy sometimes to have a slicer which allows you to get better data into a 3D program, into a CAD processing environment. It's notoriously difficult to get some 3D item types into other CAD programs, so the slicing utility was added to allow both 3D printer hobbyists as well as people who want to import 3D data into things like Rhino an opportunity. You simply slice the object. We'll just do a quick slice on this beveled as an example. And once the object is sliced, let's animate that so you can see all the slices as they go through. Once they're sliced, you can say export as a DXF and then import them into a program like Rhino. I've tested in Rhino. I haven't tested in any other CAD program for that. The playing card output here is simply for me to use, but it's there just in case it's useful to anyone, and you'll find that in the slicing video as well. My point, I guess, in all this is to show you that there are many ways, many things that you can do in Gearotic, and there's a lot of videos that you should watch if you want to become proficient at them, because I have skipped over a million things in this short video. In Circular, you have things like gear train calculators, which can allow you to create entire gear trains with a few clicks of your mouse. There's a lot of things to be learned from the videos, and when you see that things are different from the graphics interface that's facing you to what's in the video, interpolate the data in the video across to the new interface. I don't think that you'll find it too hard in the end to jump back and forth. And don't be scared to ask on the forum for assistance. We really don't mind helping people out when you get into a project and you find that there's something that you want to do. We're sure that bugs exist in all this. It's getting to be a fairly complex program. So let us know if you find something that looks a bit strange to you so that we can get that fixed up for you and for others. Well, we hope you enjoy the program, and Gearotic2's development rolls along. We'll catch you in the future.